All right, in this quiz we covered a stoichiometry problem, and it's a limiting reactant problem, and we're going to kind of break it down into some steps, and that was really how the quiz was laid out. So the first part says, what is the mass in grams of the carbon dioxide, one of the products, that's going to be formed from combusting 100 grams of propane, C3H8, in as much oxygen as you need. And when we're doing a limiting reactant problem, which this will walk us into, this is really the first step, is we want to assess for each reactant what happens if the other is in excess. And for now, if that wasn't kind of clear throughout the quiz, that is sort of what this step is covering. So here we have as much O2 as we want. We have a certain amount of propane. And we want to say, well, the process of doing a stoichiometry problem is we go from the mass of the propane to the moles of the propane to the moles of the CO2 and then the grams of the CO2. This progression is critical to stoichiometry. And this is because when we're looking at the balanced chemical equation, we have to use moles. This says that 1 mole of C3H8 plus 5 moles of O2 goes to 3 moles of CO2 and 4 moles of H2O. Or that 1 molecule of C3H8, 1 molecule of propane, plus 5 molecules of O2 goes to 3 molecules of CO2 plus 4 molecules of H2O, water. It is the number that's in proportion within this chemical reaction. Within the conversion here, to go from grams to moles to grams, we need to use different conversions for each of these steps. And so to go from grams of propane to moles of propane, we use the molar mass. To go from moles of propane to moles of CO2, we use the mole ratio out of the balanced chemical equation, basically the coefficients within the balanced chemical equation. And to go from moles to grams of CO2, we use the molar mass of carbon dioxide. And I've pulled up those numbers here. They're pretty similar, but that doesn't really change things too much. And here they are. So how do we actually calculate the problem? Well, we start with what we know. That's our 100 grams of propane. And we convert it to moles using the molar mass of the propane. Grams will cancel. Now we can convert it to the moles of CO2 using the balanced chemical reaction. And note on this step that we've gotten it into units of moles of C3H8, and we know that for every mole of propane that's consumed, 3 moles of carbon dioxide are formed. And that's exactly why we want to apply this conversion here, because that's what this says. It says we get 3 moles of carbon dioxide per each 1 mole of propane. And then if we apply that conversion, we're going to get to moles of our carbon dioxide. Now we convert to mass of carbon dioxide, and that's pretty much the whole problem. We evaluate the whole thing, and we get 299.4 grams of carbon dioxide are formed from 100 grams of propane in excess oxygen. The next question is saying, well, what if we have 300 grams of oxygen in excess propane? How does this question change? And so really the process is exactly the same, right? We're going from grams of oxygen now to moles of oxygen to moles of CO2 to grams of CO2. Now instead of the molar mass of the propane, we're going to use the molar mass of the oxygen to get from grams of oxygen to moles of oxygen, then the mole ratio again, and the molar mass of CO2. Here are those values again, but now I've added on the molar mass of O2, so sort of updating our molar mass understanding, our little table on the side. And we go from 300.0 grams of O2 to the moles of oxygen using the molar mass of oxygen. Now we can use the mole ratio. And again, this is the real chemistry step. And what we've extracted from the balanced chemical equation, that's the reaction that shows we go with propane plus 5 O2s to 3 carbon dioxides and 4 waters, is that for every 3 carbon dioxides that are made, 5 moles of oxygen are required. And that's exactly what we're putting in the middle here. This is going to change our units from moles of oxygen to moles of carbon dioxide. And now we can get the mass of carbon dioxide, so the moles are going to cancel, and we find the following result, which is to say that if it's as much propane as we need with only 300 grams of oxygen, we obtain 247.6 grams of carbon dioxide. Okay, so the last bit here is really kind of getting at the limiting reactant question here. So if we have these two examples, the 100 grams of C3H8 in as much oxygen as we need versus 300 grams of oxygen in as much C3H8 propane as we need, which one is going to make more product? And if we review, we saw that 100 grams of propane in excess oxygen made 299 grams of carbon dioxide, while 300 grams of oxygen in excess propane made a little bit less. And therefore, based on this, we're going to say that less was produced in part B. And therefore, if we combine the 100 grams of propane with the 300 grams of oxygen within only this reaction, it's going to be the oxygen that's consumed first. Because when we make 247.6 grams of carbon dioxide, all of the oxygen is going to be used up. That's the amount of oxygen that will be required to make this. 300 grams is required to make 247.6 grams of carbon dioxide. However, the propane will still be available because 100 grams of propane can make up to nearly 300 grams of carbon dioxide, and therefore it won't have been completely consumed yet. Oxygen is in this case our limiting reactant. The final question is, well, what mass of carbon dioxide are we actually going to get if we combust 100 grams of propane in 300 grams of oxygen? And the answer here is really just this answer that we got in part B. We've already figured all this out. And if we combine these two, we see, well, the propane is in excess, the oxygen is limiting. Therefore, it's the limiting reactant that is going to determine the amount that's produced. The excess would be able to make more, but it can't because we're limited by what's actually the limiting reactant here, and therefore 247.6 grams of carbon dioxide are what is actually produced from this combination.